Falcon 9 lands on landing zone 1 for the very last time. NASA's Artemis II crew performs an important test. Companies around the world receive contracts for moon rovers, and we've got a bunch of news about launch pads. As always, we'll have all that and more coming up this week in spaceflight. Well, another week, another bunch of news about lunar missions. So let's dive into it, starting with Artemis II, NASA's mission to launch humans on a trajectory around the moon for the first time since the early 1970s. The SLS rocket is now mostly stacked in the vehicle assembly building and is undergoing loads of testing. Meanwhile, the Orion capsule is hanging out at the Multi-Payload Processing Facility, or MPPF, where it's being loaded with propellants and other commodities. But this week, the MPPF was also the site of an important test with the entire Artemis II crew. The astronauts got suited up and headed there to test drive Orion before flying it around the moon. This test is called the Crew Equipment Interface Test, and it's been performed for many vehicles, including Shuttle, to allow the crew to familiarize themselves with the spacecraft that they're going to fly in.
We are excited that today is the first time that we will all be in the vehicle since it's been in this facility, and we're going to be in there together, which is really exciting. That's a first all around. Some of us have had different opportunities to interact with flight hardware on different trips, and obviously that's always an incredible day. But when you're in your launch and entry suits, you're with your crew, you're going to be on the pad with, that is absolutely phenomenal. There are more tests that we're coming back for, actually even in a couple weeks. There are crew countdown tests, there are joint sims, there is launch and recovery training for different situations after splashdown. There's a lot of really real dynamic training events coming up over the coming months, and we're so eager to execute those.
Meanwhile, teams are working to get the rocket and the ground infrastructure ready for flight. NASA recently completed testing of a new hydrogen sphere, a massive storage tank that holds cryogenic liquid hydrogen before it's loaded into the booster. If you followed along with Artemis I, you'll remember that the availability of liquid hydrogen was a major factor when making decisions about launch attempts. This new tank should shorten that time and allow for more opportunities. What's more, the SLS rocket and its Orion crew capsule are still being worked on.
There are things on the operations side that the crew is always watching, but then there's things on the technical side, and let's be honest, we are not the ones watching them, but we're aware of them. So our side hatch is a fairly complicated hatch, and there are some issues with that, so we're still watching as they're pressing through that. They just finished installing some strakes up at the upper booster make point on the core stage of the SLS, so that was interesting to watch them go through that and do some open heart surgery and install those. That's really fascinating to me. But every week we sit down with our flight operations leadership team and we get a briefing on exactly where we stand on all these technical issues. And then we come down to Kennedy, we get to go see the vehicle, see the people. Really, when you get to go stand next to the small team of men and women that are assembling this vehicle, cutting into it, making mods, and doing all the systems testing, like that's where the rubber hits the road, and you really get to know this vehicle and you really get to love these people.
NASA really hopes to get the final issues checked out and the rocket ready to fly before April of next year, or earlier if possible.
Because the launch date is no later than April, the only way to actually make it no later than is to have some options to pull that forward. And so we will be ready when the vehicle and the team are ready.
While Artemis II and its crew are getting ready for launch, preparations for the mission after are already in full swing, including the very first pieces of hardware for Artemis III arriving at the Cape. This week, the so-called boat tail rolled into the vehicle assembly building. It's a sort of fairing that will be installed on the bottom of the SLS core stage to protect the sensitive hardware and the RS-25 engines, and it'll be mounted to the engine section, which also arrived at the VAB this week. From pictures posted on social media, it seems that the two pieces have already been stacked, though it might take a while for NASA to precisely align the parts and fasten all 360 bolts. Ultimately, the section will be moved to the VAB's High Bay 2, where the SLS core stage will be integrated. Officially, NASA still aims to fly Artemis III in mid-2027, but it seems very unlikely that it'll be able to meet that date. One of the goals of Artemis III is to land humans on the moon in SpaceX's Starship human landing system, and many pieces need to come together for the agency and its commercial partners to meet that date. Besides the rockets and the spacecraft, the mission also requires spacesuits and a lunar rover, and it seems unlikely that all of them will be ready in time. Though we are, of course, very excited to see humans return to the moon, Artemis also includes uncrewed missions through NASA's Commercial Lunar Payload Services, or CLPS program. This week, the agency awarded a contract to Firefly Aerospace for another lunar mission under this program, the fourth such contract for the company. In March, Firefly's Blue Ghost lander became the first commercial lander to successfully land on the lunar surface. Others had previously touched down, but they all experienced some sort of issue, such as landing in the wrong orientation. Blue Ghost's textbook performance represented a great victory for Firefly, and it was also the first complete success for the Eclipse program. On the heels of this achievement, NASA has now contracted Firefly for a fourth Blue Ghost mission in 2029. Mission 2 and 3 are scheduled for 2026 and 2028 respectively. This newly announced Mission 4 will head to the lunar South Pole, where it'll deliver 5 rovers and instruments. First, there's the Stereo Cameras for Lunar Plume Surface Studies, or SCALPS payload. Now, if you've been following along with the CLIPS program, you might already recognize that name. A similar instrument has been installed on most CLIPS landers to study how rocket exhaust interacts with the lunar regolith. Another regular is a laser retroreflector array. This passive instrument helps to precisely determine the positions of spacecraft and landers and can be used as a location marker on the moon for future missions. Firefly will also outfit Blue Ghost with a robotic arm with a titanium shovel. This allows NASA to scoop up some soil, or lunar regolith, which can then be analyzed by a mass spectrometer to determine its composition. And then there are 2 rovers. First, there's Moon Ranger, a tiny rover developed by NASA in collaboration with Carnegie Mellon University and Astrobotic. Moon Ranger will roam around to take images and study the composition of the regolith with its neutron spectrometer system. The Canadian Space Agency will supply the second rover, which will be outfitted with a whole suite of instruments to study the lunar surface. The rover will drive around the moon and explore the permanently shadowed regions near the South Pole. It's also designed to withstand the harsh conditions of the lunar night and aims to survive at least one of them. But this is just the beginning of Canada's plans to roam the lunar surface. This week, CSA announced that it has awarded 3 contracts to study different options for a lunar utility rover. Now, this will be a much bigger rover designed to support missions to the moon. CSA envisions that it might be used for logistics like moving cargo, in addition to preparing landing pads, laying cables, or supporting astronauts during moonwalks. It could also conduct science and search for additional resources such as water ice. The rover will be designed to last for at least 10 years on the lunar surface and will be operated from Earth as well as by astronauts on or near the moon. Now, that's no easy task, so CSA has awarded a total of 14.6 million Canadian dollars to 3 companies to study what it takes to make it happen: Canadensis Aerospace Corporation, MDA Space, and Mission Control. These companies have 18 months to develop different concepts for this rover, and Mission Control even wants to build a prototype. Presumably, CSA will then select 1 or 2 options after this initial phase. But what if a lunar rover could also serve as part of a moon base? Well, Talisenia Space wants to make one. The company has signed a contract with the Italian Space Agency to start working on the design of a multi-purpose habitation module. Unlike the rovers currently in development for Artemis, this one has a large pressurized compartment. But that shouldn't really be much of a surprise because pressurized modules are the company's bread and butter. Talisenia built the pressure vessels for many of the ISS's current modules, for the Cygnus capsule, and they're working on Axiom's forthcoming space station and also the Lunar Gateway Station. But put one on wheels and you've got a lunar rover. It's a bit more complicated than that, of course, as it needs to survive the harsh conditions on the moon's surface and withstand lunar night, all the while driving around and providing safe accommodation for astronauts. Like Canada's rover, this one is also supposed to have a lifespan of 10 years at minimum. Ultimately, Talisenia believes that the rover habitat combination could be the first step in establishing a permanent moon base. The contract awarded by the Italian Space Agency covers a 2-year preliminary design phase, which will mainly focus on the development of the technology needed to handle the lunar environment. If all goes well, the rover is planned to launch from the Kennedy Space Center in 2033. Rocket Lab has nearly completed the build of its new Launch Complex 3 within NASA's Wallops Island in Virginia. The new launch pad officially opens next month and will undergo a series of operational readiness tests for the arrival of Rocket Lab's reusable Neutron rocket and its maiden launch later this year. Construction began at the Mid-Atlantic Regional Spaceport, or MARS, in late October 2023, and the site is tailored specifically to Neutron. The pad includes a robust launch mount designed for rapid turnaround and an 86-meter tall water tank tower that holds 200,000 gallons of water for the deluge system, which we saw being tested back in May. The new pad is situated literally next door to Launch Complex 2, which Rocket Lab already uses for Electron launches into low Earth orbit, as well as for suborbital missions for its HASTE program. According to Rocket Lab, the adjacent complexes have sufficient propellant storage to support launches just 24 hours apart, with LC-3 being a favorable choice for Neutron, which will require a lot of launch availability. Rocket Lab is currently the only operator going to orbit from the Wallops facility, and with the arrival of Neutron in the coming months, Wallops is certainly going to get a lot busier. Meanwhile, at Cape Canaveral's Launch Complex 14, Stoke Space is on course to bring this historic launch site back online by early next year. You may remember that we showed progress on the flame trench in a recent episode. Well, Stoke has been renovating the site since last July and hopes to launch its reusable Nova rocket from this pad in early 2026. With earthworks now largely complete, the superstructure for the horizontal integration facility continues to take shape and will be fully enclosed by September. This building will support final checkouts and payload integration before Nova is transported horizontally to the pad, then raised vertically for launch. The launch pad is well under construction, with concrete pilings and rebar now in place. The umbilical tower, which will deliver power and propellants to Nova while on the pad, is also already built and awaiting final integration. Over in the flame trench, a water-cooled stainless steel flame diverter is currently under construction, and storage tanks are starting to appear at the tank farm. With the pad continuing to develop daily, Stoke appears on track to complete the build and get Slick 14 operational just a year after work on the pad first began. Stoke's pad lies adjacent to landing pads 1 and 2, which SpaceX has periodically used over the past 10 years for return to launch site or RTLS missions, landing both Falcon 9 and Falcon Heavy boosters there. Almost a decade ago, in December of 2015, it was the site of SpaceX's first successful landing of an orbital-class booster when B-1019 successfully landed during the Orbcomm OG-2 Mission 2. This week, the company announced that the Crew 11 mission would be the final landing on the concrete pad at Landing Zone 1, or LZ-1 as it's more commonly known. With the lease about to expire, SpaceX's VP of Build and Flight Reliability, Bill Gerstenmaier, confirmed that the pad will be retired following booster B-1094's landing for that mission. SpaceX will continue operations at neighboring LZ-2 for the short term until the lease expires on the former Launch Complex 13, which houses the 2 landing pads. LC-13 will then be reassigned to Phantom Space and Via Space. Updated regulations now require landing pads to be located at the launch complex. SpaceX has already submitted a launch license modification for Slick 40, its busiest launch site, which includes the construction of a new on-site landing zone that would accommodate up to 34 first-stage landings each year. Meanwhile, in Canada, Nordspace has broken ground at a new launch site in Newfoundland and Labrador. Construction has now begun on the first of 2 pads at the Atlantic Spaceport Complex, a commercial spaceport that will support the first ever orbital launch from Canadian soil. The spaceport will support equatorial to polar orbits with a wide range of launch inclinations. Construction of the first pad is expected to take a year, followed by an additional pad for the orbital launch vehicle of an undisclosed partner in 2028. This second pad is intended for third-party or US-based launchers under a technology safeguards agreement. Nordspace will use the new pad for the maiden flight of its Canadian-built Taiga rocket, which uses the company's 3D-printed Hadfield engines. Taiga will perform suborbital flights and hypersonic tests, carrying around 50 kilograms of payload to the Kármán line. It serves as a stepping stone towards Nordspace's orbital-class launcher, Tundra, which is currently targeting a maiden launch in late 2027. This will carry up to 500 kilograms to low Earth orbit, and it's designed to be transportable in sea containers to support responsive launches from other locations. Now we'll take a look at some other stories across space, including the coolest story that you're likely to hear this week. Teams at NASA's Marshall Space Flight Center in Alabama have been working on an innovative technique to avoid liquid propellants from boiling off in space. The approach could help prevent the loss of valuable cryogenic propellant during long-duration space missions and was demonstrated with liquid hydrogen and 2 stages of active cooling. Now you might be thinking, the vacuum of space is already cold, so why is this a problem? Well, temperatures in space can be as low as negative 268 degrees Celsius, but despite this, the low boiling points of cryogenic propellants, such as liquid hydrogen and oxygen, can put them at risk for boil-off. Solar radiation, onboard systems, and even spacecraft exhaust can all contribute heat. But this new technique aims to help spacecraft tanks keep their cool. In this first-of-a-kind demonstration, helium was chilled to around negative 253 degrees Celsius and circulated through tubes around the outer wall of the propellant tank. An insulation blanket was then wrapped around the tank containing multiple layers, including a thin aluminum heat shield and a second set of tubes carrying more helium at negative 183 degrees Celsius, which acts as a first layer of protection from external heat sources. NASA's demonstration will last until September, spending 90 days in the vacuum chamber. To date, cryogenic propellants have only been used for missions lasting less than a week, and a little loss can be factored into the propellant margin. However, deep space missions, supertankers in low Earth orbit, and missions to the moon will all require technology like this for better management of their onboard liquid propellants. Blue Origin has also announced significant progress this week on its own zero Boiloff technology. This will be critical for its Blue Moon Mark II lander, which will eventually carry astronauts to the lunar surface. They've been demonstrating the ability to retain liquid hydrogen and oxygen at 2 times the performance of their current systems. Their prototype flight hardware held its super low temperatures and also met all of NASA's objectives. Axiom Space has completed the final weld on the first module for its Axiom space station. The Payload Power and Thermal Module, or PPTM, will be the first of 5 planned modules for the commercial station to head into low Earth orbit. Late last year, NASA asked Axiom to review the order of the modules to accommodate plans to decommission and deorbit the International Space Station by the end of the decade. Revising the assembly order also brought forward the timeline for Axiom's commercial station to become an independent orbital platform by 2 years. So how do they do this? Well, by sending up the PPTM first, rather than a habitat module, Axiom can undock from the ISS sooner because that module provides all of the power and core systems for independent operation. The PPTM is currently expected to undock from the ISS and become a free-flying station as early as 2028. The first of 2 planned habitat modules will later rendezvous and attach to this core module as the commercial station begins to grow. They'll later be joined by an airlock module, a second habitat module, and finally, the RMF, or Research and Manufacturing Facility. This will be a dedicated microgravity and production module that also has a panoramic Earth observatory larger than the cupola on the ISS. To accelerate construction, the primary structure for the PPTM was built by Talisenia Space in Italy, with integration of the internal structure and systems at Axiom's facility in Houston. Completing the final weld just 250 days after fabrication began marks a major milestone in Axiom's accelerated timeline. Final integration will continue into next year, with a launch to the ISS targeted for no earlier than 2027. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. It was a busy week with launches from all over the world, starting with a long-anticipated launch from Australia. It didn't end well though, so let's go over to Ryan for an analysis of what happened down under.
The first Australian-built orbital rocket just took flight for the first time, but it didn't quite make it to orbit. So what happened? Well, after months of regulatory setbacks, weather delays, and the accidental separation of the fairings while still on the ground, Gilmour Space's 3-stage Eris launch vehicle finally took off from the Bowen Orbital Spaceport on Wednesday morning local time. However, not even a second into flight, an engine started to see some trouble. The exhaust definitely didn't look correct, looking too yellow in colour and very unstable in shape. The 30 metric ton rocket then started translating in the direction of the failed engine, indicating that it was producing very little to no thrust whatsoever. Each of the 4 Sirius engines on the first stage produces 115 kilonewtons of thrust as of the most recent data provided during the final qualification test in 2022. In a normal scenario, this would give Eris a thrust-to-weight ratio of 1.5 at liftoff, which, judging by the first half second by eye, looks to be about correct. However, if you take away one of those engines, the thrust-to-weight ratio drops to 1.2, or in other words, the thrust of the 3 remaining engines is barely enough to keep the rocket slowly climbing, which we can also see from the awesome video provided by Gilmour Space. The 3 remaining engines are also not symmetrically placed around the centre of mass, resulting in the power slide. Approximately 9 seconds after liftoff, with the vehicle slowly climbing, what appears to be some white gases are quickly ejected from the aft end of the vehicle. Unfortunately, this is on the opposite side of the rocket for the close-up camera, but it simultaneously results in the vehicle starting to slowly fall down to the ground. This is indicative of a second engine failure, leaving only 2 running. By doing this, the thrust-to-weight ratio drops to 0.78, or in other words, there is not enough thrust to keep keep the rocket going up, but there is enough to stop it falling down to the ground straight away, which is why we can then see this slow, graceful, accidental propulsive landing until the vehicle hits the ground and tips over. The fact that engines failed on the flight was also confirmed by the head of avionics at Gilmour on X, but they did not confirm which engines failed, probably because the video speaks for itself. It should also be noted that the Sirius engines on the first stage can't gimbal or steer themselves to point the rocket. Instead, it uses reaction control thrusters for steering. But why didn't it blow up? Well, it did, just not straight away. That could be explained by the fact that the first 2 stages are hybrid stages, but beware, we're entering wild speculation territory. Stage 1 and Stage 2 use liquid hydrogen peroxide as the oxidizer and a solid fuel as the fuel. There is the possibility that because of the slower touchdown and solid propellant, that the possibility of a rupture straight away was minimised until the vehicle tipped over and the kerosene-oxygen third stage impacted the ground. But again, wild speculation, and Gilmour has not said anything surrounding the explosions witnessed. Next up will be Flight 2, which will follow a huge data review. Gilmour says that is currently scheduled for within 6 to 8 months, which if they could pull that off would be mighty impressive. Something else that was impressive was the fact that even with half of the engines failing, Eris managed to keep itself pointing upright during the entire flight. A huge shout out to the Gilmour guidance, navigation and control team for that. That was just incredible to see.
Later in the week, Gilmour posted on social media that it had recovered the rocket's payload from the rubble, a jar of Vegemite. It looks a little bit battered, but the company believes that it's serviceable and reported that the payload is safe. This week, like during most other weeks, we saw a few Starlink missions, 4 in fact, adding a total of 99 satellites to the constellation. We also had 2 launches for internet constellations from China, where a Changzheng 6A and a Changzheng 8A launched 5 and 9 satellites for the Guowang or SatNet constellation, respectively. While the constellation is still small at this stage, it's intended to grow into a true mega constellation with around 13,000 satellites. Also from China, we had the launch of a Pakistani Earth observation satellite atop a Kuaizhou 1A from X-Pace, and a Chinese Earth observation satellite on a Hyperbola 1 from the Chinese company iSpace, with a capital S, not to be confused with the Japanese lunar exploration company iSpace, all lowercase. This flight marked the return to flight for this rocket after last year's failure. Over in India, a GSLV launched a joint mission for NASA and the Indian Space Research Organization. The NASA ISRO Synthetic Aperture Radar Satellite, or NISAR for short, will study our planet and map Earth's surface to observe changes as small as a centimeter. With this data, the agencies want to study ice sheets, agriculture, changes in soil moisture, and even vegetation growth, among other things. From Europe's spaceport in French Guiana, we had the launch of a Vega C carrying 5 satellites into space. One of the satellites was the Microcarb satellite for the UK Space Agency and the French Space Agency CNES, which will study carbon dioxide in our planet's atmosphere and how it's emitted and absorbed throughout the world. The other 4 satellites are the CO3D mission from CNES, which will observe our planet's surface for military and civilian purposes. And closing out the week, we had the launch of SpaceX's Crew 11 mission to the International Space Station. Crew Dragon Endeavour carried a crew of 4 up to the ISS, commanded by rookie NASA astronaut Xena Cardman. The pilot of the mission is NASA astronaut Mike Fink, who's now on his 4th mission. The mission specialists are Kimiya Yui of Japan, flying to space for his 2nd time, and Russian cosmonaut Oleg Platonov on his 1st mission. The 4 are set to arrive at the station on August 2nd. The mission also marked the last booster landing on Landing Zone 1, which we covered earlier in the episode. And hey, did you know that this mission's crew assignment was heavily informed by last year's Starliner drama? We made a video explaining the situation if you want to learn more. As the calendar has now flipped to August, it's time for some statistics. Throughout the month of July, we saw 24 launches. As always, SpaceX led the pack with 13 Falcon 9 launches, including the rocket's 500th. China followed with 6 successful missions, and the month's single failure was the aforementioned Eris launch, which also added a new launch operator country to Alex's spreadsheet: Australia. Next week, we'll have even more launches for internet constellations. Currently, there are 2 Starlink missions scheduled, one from Florida and one from California. Falcon 9 is also set to launch its 2nd mission for Amazon's Kuiper constellation from Florida. And it looks like we'll also have another launch for China's SatNet constellation, this time atop a Changzheng 12 from Wenchang. From New Zealand, we'll have an Electron launch carrying up an Earth observation satellite for Japanese company IQPS. We'll also have some crew operations next week. Blue Origin's New Shepard is scheduled to lift off from West Texas, carrying 6 passengers to just over the Kármán line. Among them is the winning bidder for the rocket's first human mission in 2021, who missed the flight due to a scheduling conflict. Over on the ISS, Crew Dragon Endurance is also set to undock on August 6th, returning the Crew 10 astronauts back to Earth. As always, things might change, so keep an eye on our next spaceflight app and website for the latest updates. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap This Week in Spaceflight.